Dear students, in this video, we will understand what is a modulus function or an absolute value function. Generally, in first PUC Karnataka PU board exam, they ask us to define one of the functions, draw the graph and write the domain and range of the function. This is one of the important questions which is asked for 5 marks in part D, first PU question paper. That is why you need to understand the modulus function. We use this modulus function or absolute value function during the course of the first and second PUC. So it is very important for us to understand the definition, domain and range of graph of the modulus function or absolute value function. So the absolute value function or modulus function is written like this. F of x is equal to mod x for all x belongs to R, for all x belongs to set of real numbers. So from this we can understand the domain of the modulus function is set of real numbers. Okay, we'll check that later. Now, if you consider a number line, this is 0 and to the right side of the 0 is all positive numbers and to the left side of the 0 is all negative numbers. This is already known to us. So to the right side of the 0, it is x is greater than 0. That is x is positive. To the left side of the 0, x is less than 0 where x is negative. How is the function defined? Before checking the actual definition, let us understand the function is defined like this. Y is equal to f of x. This is equal to modulus of x. Modulus of x is x when x is greater than 0. Even x is greater than 0 and in for equal to 0, the function is always defined like this. Modulus of function is mod x is equal to x. That is whatever the value of x is, mod x is that only. If our x happens to be 2, that is because we are checking the to the right side of the 0, x is greater than 0. For that condition, we are checking the function. So if x happens to be plus 2, f of 2 is modulus of 2, which is 2 itself. So whatever the x was, the answer is also x. So it is modulus of 2 is 2. Modulus of 3 is 3. Modulus of 10 is 10, like that. Now, when it is for 0 also. So f of 0, you consider f of 0, mod 0 is 0 itself. Now let us check when x is less than 0. When x is less than 0, that is to the left side of the 0, you consider f of x is equal to, that is y is equal to f of x is equal to modulus of x, where x is negative, is minus x. Here, when x was positive, the function was defined as mod x is equal to x itself. But in this case, mod x is equal to minus x. Why is it minus x? That is because if x happens to be minus 2, f of minus 2, that is modulus of minus 2 is equal to, how is it defined? Minus x, right? So minus of x is minus 2, so minus 2. It is plus 2. So even if the x is negative, the value is plus 2. Why are we doing this? Modulus function is nothing but the distance of any given x from 0. That is, if x is positive, we can directly write the distance or at what distance is the x from 0. If it is negative, we are ignoring the negative sign and writing the distance only. We would have already come across this. Modulus of minus 2, we directly write it as 2. That is, we are checking the magnitude of the value of x, whether it is positive or negative. It is f of minus 5 is 5 itself. Modulus of minus 2 is 2. Modulus of minus 5 is plus 5. Modulus of 0 is 0. Modulus of 100 is 100 itself. Modulus of minus 150 is 150. So we are considering the distance of the value x from 0, whether the distance is to the right side or whether the distance is to the left side. We are finding the distance. So whenever x is negative, the function will be not just x, it is minus x. So x is already negative and with a negative sign, minus of minus will make the function positive. That is absolute value, which makes it a positive quantity. So hope you this part of the function is clear. Now let us check the definition. Whenever you are asked for 5 marks, you have to write the definition, and this is the definition you have to write. You have to write the graph domain and range. That much is sufficient for 5 marks for first PU. So the function is y is equal to f of x is equal to modulus of x. The function is again divided or written in two parts. That is, when x is greater than or equal to 0, the function, that is x is equal to 0, and when x is greater than 0. In both the cases, the modulus of x will be x itself. But when x is negative, that is less than 0, as we have understood here, it is not just x, it is minus x, so that the value what we get, the modulus value should be positive. There is a negative sign that is being introduced. So this is the definition of a modulus function. To understand this, f of x is equal to x when x is greater than or equal to 0. F of x is minus x when x is less than 0. That is, y is x when x is greater than or equal to 0. Y happens to be minus x when x is less than 0. Now let us check the graph of this function. Remember this, when x is greater than or equal to 0, it is f of x is equal to x. That is, y is equal to x. Y is the codomain element, right? Less than 0, it is minus x. Now let us check the graph of this function. See, this is origin 0, 0, and this side it is x is positive and this side x is negative, right? Here y is negative, that is below x-axis. Above x-axis y is positive. This part we already know. Now when you say x is greater than or equal to, it is this part. When x is greater than or equal to 0, how is the function defined? We have just understood it is y is equal to x, which is nothing but a straight line passing through origin. But modulus function is always positive. That is, y is never negative. So whenever we consider the coordinates, if x is 1, then y happens to be 1. That is, mod 1 is 1. If x is 2, that is mod 2 is 2. Like that. It is always positive. So since it is always positive, the graph of the modulus function never goes below x-axis. So it is here passing through origin. So it will not come here. Y is equal to x. Below x-axis will not appear in case of modulus function. Only in the first quadrant, only in this part, it is y is equal to x. When x is less than 0, that is negative. Modulus of minus 2 is 2 itself. This is x comma y, right? When x is minus 2, y is plus 2. When x is minus 3, mod minus 3 is 3 itself. So it is here. You can see y is always positive, as we have understood. Modulus value or absolute value gives us always the quantity. So it is always the positive value. Again, the graph is above x-axis even for this region. When x is less than 0, the graph is above x-axis. But it is y is equal to minus x. This is the form of the equation. Together, this is the graph of the modulus function. We just have to write this. Now, if we check the domain and range, domain is the set of all real numbers. And what is the range? Range is the set of all non-negative real numbers. Set of all non-negative real numbers. That means the y value is always positive. It is 0 and greater than 0. It can never be negative. So it is always non-negative real numbers. So now if you draw a line parallel to x-axis, what happens if you draw a line parallel to x-axis? The line meets the curve at 2 points, right? You draw a line parallel to x-axis. It meets the curve at 2 points. That means definitely this is not a 1-1 function. Now let us check two important properties of modulus function. The first one is mod x less than or equal to a. When mod x is less than or equal to a, where does the value of x lie? So first let us take an example. Mod x less than or equal to 2 is what I am considering now. When we say mod x is less than or equal to 2, it is the distance of x from 0 is less than 2 is what is the meaning of this. So when you check on the number line, 0 is here and its distance is less than 0. If you consider this side also, the distance from 0 to 2, the distance is less than or equal to 2. You can consider 2 also when it is less than or equal to. If you consider this side, the left side of 0, even in this case, the distance is less than or equal to 2. So, x value lies from minus 2 to plus 2. Whenever x lies from minus 2 to plus 2, its distance from 0 is always less than 2. That is what is the meaning of this modulus of x less than or equal to 2. That means distance of x from 0 is always less than or equal to 2. That is the meaning. So, where does x lie? X value lies from minus 2 to plus 2. If it is strictly less than, then we can consider strictly less than here. In general, what we can write? Minus a less than or equal to x less than or equal to a. We can consider this in general. Now, in the second case, when mod x is greater than or equal to a, when mod x is greater than implies and implied by, let us consider mod x greater than or equal to 2 only. What is the meaning? Distance of x from 0 is greater than 2. That is what is the meaning. Modulus of x is greater than or equal to 2. When is the distance from 0 greater than 2? Definitely, if the x value lies here, then the distance of x, any x in this case, from 0 will be definitely more than 2. Again, if you consider the negative side of the number line, you consider any negative number here which is less than minus 2, definitely its distance from 0 is more than 2. That means we are not considering the value of it, we are considering the absolute value, that is the distance from 0. Distance from 0 here for any value of x is definitely greater than 2. So what we can write here for modulus of x greater than or equal to 2 is mod x, or x is less than or equal to minus 2. Correct? X has to be less than minus 2 for its distance to be more than 2 from 0. Or it can be here also. X can be greater than or equal to 2 also. X can be greater than or equal to 2. If x is less than or equal to minus 2 or x is greater than or equal to 2, in both the cases, its distance from 0 is greater than 2. So what we can understand is x is less than or equal to minus a, or x is greater than or equal to plus a. Dear students, if you have any doubt, please do mention it in the comment section. Now let us understand the modulus function graphically. This is the graph of a modulus function. Suppose let us make small change. This is only for your understanding how the graph looks. If I write modulus of x minus 2, you can see how the graph changes. The graph shifts 2 units to the right side. If for x modulus of x minus 2. Similarly, if I make this as modulus of x plus 2, the graph moves 2 units to the left. And if this is only for your understanding, if I write mod x plus 2, if I say mod x plus 2, then it shifts 2 unit upwards. If this happens to be mod x minus 2, then the graph moves below x-axis. Modulus function graph is this. If you have any doubt, let me know in the comment section.